children, so welcome to this registers connected in series and registers connected in parallel. So these two concepts are registers connected in series and parallel. In board examination of our ICC, and even in the class 10th CBSE, we get a 5-mark question from this circuit diagram. Either 4 marks and related to this circuit diagram, 1 in MCQ. So total 5 mark will be there. Just we have to understand this concept, registers connected in series and parallel. When will you know that registers connected in series? Current to flow through them, first of all. Allow the current in between the two terminals A and B, and when the current passes through this I current, let me allow the current I. When I current passes through the resistor R1, it remains only I. When it comes to R2, it remains also the same branch only, it is flowing through that, that's why current remains as I only. Even in R3, even in R4, that till Rn. If I connect n number of resistors in series, then current remains same in all the resistors. Then we say that the resistors are in series circuit. I have drawn another example. You can see a branch structure. This is one kind of connection to the resistors in disguise. Many will be thinking that maybe this all the resistors are connected, somewhere maybe parallel, somewhere maybe switched. No, children, you have to allow the current. So main keyword is just to remember the current. Allow the current to pass through. Is there any other way through which current can deviate? No. This is the only the path through which current can flow. You can see the same amount of current flows. There was a student asked me the doubt. If sir current flows to the resistors and you said sir in the resistors they obstruct the flow of current. If some amount of current is dropped here, then other current amount will be dropping to the another one resistor. Children, let me tell you, voltage drops, not current drops. Okay, voltage drops but not current drops. And as per our concept, voltage remains same in parallel circuit and current remains same in series circuit. Don't forget this again, two concepts I say you. Current remains same in series circuit and voltage remains same in parallel circuit. The opposite, that means voltage changes in the series circuit and current changes in the parallel circuit. Remember. Now here also current I is there, that's why current I comes through this way. Second branch I, same current. So these all are connected in bottom series. So what will be the equivalent resistance between the A and B terms, children? Between the terminal A and B, the total amount of resistance is called equivalent resistance. Is nothing but it is a sum of all the resistors R1 plus R2 plus R3 plus R4 plus R5. Similarly, whereas in this case current I is only flowing through I only, I amount of current flows, here also I comes. So total amount of equivalent resistance equal to how much, children? R1 plus R2 plus R3. But resistors connected in parallel, how and how will I explain that to you? If current changes in the different branch, then those branches are connected in parallel. Let me show you here. I have allowed the current to flow from the positive to negative terminal. When current I comes here, children, you are finding here Rnth branch is having I1 current, here I. And you will be wondering, sir, how much amount of current will flow through this nth number resistor and third number resistor? Depending upon the resistance, the value of the resistance. More the resistance, less the current. Less the resistance, more is the current flow. So here I3, I4, I5 and I6. So I6 current flows through this way, R1. So since current is changed in the different branches, that's why all the branches are in what, children? In parallel. Am I clear? So equivalent resistance we write here 1 by Req equal to 1 by R1 plus 1 by R2 plus 1 by R3 till 1 by Rn. This is the formula to find out the equivalent resistance when resistors connected in parallel. If two resistors are connected in parallel, that is R1 parallel to R2, in that situation you can say 1 by R equivalent equal to 1 by R1 plus 1 by R2, or you can write down only Req because you have to calculate Req is equal to, children, R1 into R2 by R1 plus R2. This is the formula you can use to get the equivalent resistance if two resistors are connected in parallel to one another. Thank you so much. Next video will be uploaded very soon related to this. Thank you.